class we shall see how can we trace polar curves. So first and foremost you should know what is a polar curve. So what is polar curve? Polar curve which is represented in these two coordinates r and theta. So these two are the coordinates in which we can represent our given curve. So how these coordinates are represented graphically? So suppose this is one axis, this is another axis. So the angle theta, that is this angle, in when you go from this direction to this direction, then you have this angle, right? So what we can do, we say this is theta is equal to 0 line. This is also known as the initial line, and whatever is the distance of this point P from this point O origin, or this is known as pole in this terminology. So whatever is this distance is calculated through a small r, right? So together the angle and this distance represent the position of a point P in this r and theta plane. So that is how we represent a polar curve. Next, the major points which are involved in tracing some given polar curve, they involve the region, symmetry, knowing whether the curve passes through pole or not. Pole in this case is the equation having r is equal to 0. Theta could be any angle. So that means when we are talking about pole, we are talking particularly about this single point over here. So the distance of this point by itself is 0, so that means r is equal to 0. Moreover, the angle theta here could attain any value. So it could be any value, because you cannot measure the angle of one single particular point. So next is the behavior of tangent, and next we'll draw some additional points, and with all this information we will draw our polar curve. So let us get started with our example. So here we have a cardioid. What is this cardioid? This cardioid is represented by this equation r is equal to a 1 plus cos theta, right? So firstly we check its region. So for that we consider what is the maximum value of r for which this curve is defined. We know what is the maximum value of this cos theta. Cos theta lies between -1 and 1. So the maximum value of cos theta is 1. Therefore the maximum value of r, it becomes a into 1 plus 1. So ultimately it becomes 2a. So it is the maximum value of r. So that means from a distance of 2a from this pole, so within this region, within this particular region, your curve will lie. So this is the first point. Next point is we will check the symmetry of this curve. So for checking the symmetry, we will change theta to minus theta. So what will this thing do? This will check the symmetry of the curve about the initial line theta is equal to 0. So that means whatever is your curve, if you treat this line as a mirror, so whatever is your curve here, the similar would be it is here. So that is the symmetry when you change from theta to minus theta. So when I substitute in place, I was having r is equal to a 1 plus cos of theta. So when I have this theta replaced with minus theta, we know cos of minus theta, this is equal to cos of theta. So we have this is eventually equal to cos of theta, so this becomes equal to r. So the curve remains unchanged. So when you replace your theta with minus theta, there is no change in the corresponding value of r. So that means the curve is symmetrical about the initial line, right? Next is we will check the symmetry of the given curve about pole. So for that, what we do, we just replace this r with minus r. So when you replace, our curve was r is equal to a 1 plus cos theta. So when you replace r with minus r, your curve will change. So we do not have any symmetry about pole for this particular curve. So this is all about symmetry. Next, let us check whether the curve passes through pole or not. So we know what is the equation of pole. The equation of pole is r is equal to 0. So when you substitute r is equal to 0, you can take this a to on the right hand side. So you would have 1 plus cos of theta. So theta ultimately comes out to be pi, right? So theta is pi. So that means whenever your r is 0, your theta is pi, that means the curve passes through pole. Why it passes through pole? Because for pole r should be 0. Theta could have any value. So this explains that your curve passes through pole, right? So next we will check at which points this meets the initial line theta is equal to 0. So here when you put theta is equal to 0 into the given equation, what you have r is equal to a 1 plus cos theta. So when you put theta is equal to 0, you would have cos 0 as 1, so it would be 2 into a. So whenever theta is 0, you have the value of r as 2a. That means the curve meets the initial line at this particular point 2a comma 0. Right. Next, we will check at which points the line meet this, the curve meets this line theta is equal to pi by 2. So what is this line? Okay, just a second. Alright. So let us move ahead. So now we will check at which points the curve meets this line theta is equal to pi by 2. So what is this line? This line is this vertical line theta is equal to pi by 2 here, because we will always start measuring our theta from this initial base line. So when you measure theta from here, from at this particular line, it would be 90 degree, right? Pi by 2. So we will see at what points your curve meet this particular axis. So for that we substitute theta is equal to pi by 2 into the given curve. The given curve was r is equal to a 1 plus cos theta. So theta is pi by 2, right? So what would cos pi by 2? It is equal to 0. So we have a 1 plus 0, so which is equal to a itself. So this is the required point where the curve meets this particular line. Theta is equal to pi by 2, right? So next we will calculate the angle which the tangent and the radius vector make. So if I denote the angle phi by if I denote this angle by phi, which represents the angle between the tangent line and the radius vector of the given curve. So this is calculated through this formula. This you have to remember, that phi, a tan of phi, that is equal to r into d theta by dr. So we have this curve r is equal to a 1 plus cos theta. So firstly what we will do, we will calculate this d theta by dr. So how can we do that? We can differentiate this curve with respect to r. So when you differentiate this curve with respect to r, on the left hand side you would have r. Differentiating it with respect to r, that would be 1. A is constant, will come as such. Then the derivative of the constant 1, that is 0. Derivative of cos theta is minus sin theta. And then further the derivative of theta. The further derivative of this theta comes out to be d theta by dr. So this is the required expression after differentiation. From here we are interested to calculate this value d theta by dr. So the value is this one. So now once we know what is d theta by dr, we can substitute this value here into this expression. So we would have tan phi as equal to r d theta upon dr. So now we will substitute its value. It is minus 1 upon a sin theta, and we can also substitute the value of r. What is r? R is given to be a 1 plus cos theta. So this a and a cancels. So we have minus as such. What is the value of 1 plus cos theta? It is equal to 2 cos square theta by 2 in half angles. And similarly, what is sine theta? It is equal to 2 sine theta by 2 into cos theta by 2. So I am using these two expressions here. So instead of 1 plus cos theta, I have 2 cos square theta by 2, and instead of sine theta, I have 2 sine theta by 2 cos theta by 2. So this 2 and 2 cancels, and 1 power of cos theta by 2 cancels with this one. So you are only left with cos theta by 2 divided by sine theta by 2, and that to negative. So negative cot theta by 2. And cot is negative in which quadrants? It is negative in second as well as fourth quadrant. So that means you can change this cot to tan by shifting it towards the second quadrant. So 90 plus the angle. 90 plus the angle. So it becomes tan pi by 2 plus theta by 2. So now we can equate the angles. Tan of phi is equivalent to tan phi by 2 plus theta by 2. So it becomes pi by 2 plus theta by 2. So this is phi. Next, we can check at which point this phi is 0. So if I substitute phi is equal to 0, what points of theta do I have? And if I substitute phi is equal to pi by 2, what are the theta values? So when you put this theta is equal to 0, you have pi by 2 plus theta by 2 is equal to 0. That is the value of phi. So from here you get theta as minus pi. So you have theta as minus pi. So this represent the angle between tangent line and the radius. So if they are having angle as 0, so that means they both cut each other at 0 angle whenever theta is minus pi, and they both cut at right angles whenever theta is 0. So this is the point that we have. Next we will see some more points in order to trace the polar curve. So from here we can draw some curves. Now what values of theta should you take in order to have complete information about the graph? So now you see, this is our coordinate system. Now we have symmetry about this particular axis. So that means whatever is up this quadrant, the same is downwards, right? So that means only information required is from 0 to pi. So we only require the angles from 0 degree to pi, 0 radians to pi radians, right? So your theta, when it is 0, pi by 3, pi by 2, 2 pi by 3 and pi, we will calculate what is r. We know what is r. R is a 1 plus cos theta. So how can you obtain r? You just substitute the value of theta here. Cos of 0 is 1, so you have r as 2a. So this is 2a. Again you put the value of cos theta as cos pi by 3, so calculate what is the value of r. R comes out to be 3a by 2, and so on. So you can very easily create this table, right? So now once you have all the table, so we are ready to draw the graph. So let us see what is the graph. The graph is something like this. So whenever we have theta is 0, the value of r is 2a. So whenever this theta is 0, theta 0 means we are talking about this particular line. So at this particular point, what is the radius or the distance covered by our curve? It is 2a. So this much distance is covered from here to here. So this is 2a. So this point is 2a comma 0, right? So next, let us see next point. It is pi by 3. So what would be pi by 3? This line is pi by 2. So this point is covered. This line is pi by 2. Theta is equal to pi by 2. So for this one, this point, the distance covered is a. So we say this much is the distance a covered. So this point is a comma pi by 2. And moreover, when theta is pi, pi is here, right? So this is pi. So here the distance covered is this 0. So all in all, you have this kind of shape. and due to symmetry the same shape is obtained on this lower quadrant. So this is our curve that we obtain, right?